first, the Airglass team will present amazing prototypes and solutions for diving in 3D with Unity. And then we will have a 360-degree camera presentation too. Then I will show you some 2D sprites and details in Unity, how to create 2D objects. Then we will have about 15 minutes pause where we will have pizzas above, and you can also check these glasses personally if you want to. No, and then Ákos will present us his glass solution, and we will close with József with this mobile applications, mobile marketing challenges. So please welcome the Airglass team, Zsolt Balai and Laci. Mihály. Okay. So.
Hello. Hi guys. Okay, hello everyone. So my name is Zsolt Balai, founder of 360 World and Airglass. I will introduce the company later in our next presentation, because in this presentation we are going to cover basically our last 2 years, so it's going to be a lot of information from hardwares and softwares as well. So we are designers, photographers, GIS and CGI experts, and we are trying to always search for our next challenge regarding hardware and software as well. And we had a vision to display virtual tracks for different kind of sports a couple of years ago, and we started to develop our hardware and software. In the first part, our first major step was when I was able to bike through augmented gates in the Margaret Island. As you can see, this was a pretty basic try. We used a PC with an IMU and with a kind of nickel metal hybrid battery, a voltage regulator, VG8 composite video converters, and so basically this is how it looked like. It was in the backpack, but it was successful. It was a lot of fun to basically go through augmented gates on the bridge, and I was trying a lot, and I realized that it's for your brain it's not really easy to understand the 3D environment and the real world as well. So the best place to use this technology is obviously in the air, where you do not have any reference points. So we decided to do some tracks in the air, and this is our next major step when a wingsuit flyer was able to fly between augmented pylons. We used this Windows Pico PC, and the track was triggered by the so-called tongue switch. So basically it was in his mouth, and when he pressed the switch, then we loaded the tracks for him. It was a really dodgy thing again, you can see. And after I think the 4th or 5th jump, basically our helmet got caught on that handle, and the VGA output was broken. So we went through and designing a more sophisticated helmet. But at this test we were also experimenting with live HD video streaming, and also streaming the gameplay of the Unity. And this is, I think, our biggest step, when we were able to load a virtual terrain. So basically we were approached by a professional wingsuit pilot who was about to fly through a mountain in China, and we modeled the hill from, I think, 19 photographs. And this is the new helmet. It's now not running on Windows, but it's Android. It's more compact, and at this point we were also able to solve the synchronization of the GoPro. So it was triggered by Wi-Fi, and that's how we were able to display on the video what he saw. So this is the helmet. This is the pilot. And at the same time, all kinds of glasses started to appear. So we went to several companies, tested their prototypes, and basically wanted to utilize. We realized that with the helmet, it's really hard to do a helmet which suits for all kinds of sports, because for example, the parachute guys told us that everything should be on the top of the helmet, because the risers, when the parachute is opening, is coming from on the side of your head. And but the aerobatic plane pilots told us that basically everything should be on the side of the helmet, because the cabin is coming to the top of your helmet. So that's why we thought it would be a better solution to use some kind of glasses. And we tried several ones, but all of them has kind of some kind of defect, so it's not suited perfectly to the purpose that we are intent to create. These were like form factor for all kinds of sporting activities. It needs to be really stable on your head. It needs to look cool, because otherwise nobody's gonna wear it. And the sensors should be high quality sensors. The display should be like bright, should be seen in bright sunlight. Some companies like Epson doing their prototypes will have a demo on this one. And for example, there is no Play Store there. There is an unnecessary controller in our thing. And there are also the camera. We don't want to embed a camera, because we can control GoPro perfectly. And sometimes it just creeps people out, like in Google Glass, that there is a camera. Also, there is a serious problem with battery, and the glasses heats up. So we decided to do our own hardware, and our hardware will be like an Oakley style design with replaceable lenses. It's going to be lightweight, it's going to be balanced, so it's not going to be, some of the glasses has a problem that basically it's one side is heavier than the other side, so it just not symmetric on your head. We want to have it compatible with all kinds of helmets. We have chosen our own sensors, our own barometers, our own IMUs. We designed it to be multi-platform, and because we think that you do not need a controller, you can use your existing smartphone. And as I said, we do not really need a camera, because we control the most versatile action camera, GoPro. We can control it. And I give it to Laszlo to speak about the software.
Yeah, hi guys, I'm Laszlo. I'm the software lead of the Airglass project, and since this is a Unity 3D meetup, I'm going to talk about Unity 3D a bit. So why did we choose Unity 3D? We were looking at alternative engines like CryEngine and Unreal Engine, amongst others, but Unity has a few features that are really important for us. Also, other engines at the time we were considering these, they were unavailable, really expensive, and most of them have features that we simply do not need. So for augmented reality, you don't really need really expensive shaders and stuff like that, which is used in games. Unity, the features of Unity, which we like, is being cross-platform. This is very important because, as Zsolt said before, this was a Windows engine, and right now we are on Android, and we are constantly experimenting with other platforms. Fast prototyping is also a must, because we test this helmet regularly, and every time problems come up, which we have to solve, and we have to solve them really fast. So a fast build and play feature is also integral to make these testing worthwhile. Unity supports a lot of file formats, which is important because we can work together with 3D artists really easily. So we don't have to make compromises when talking with other people who would help us. And when we don't have a graphic guy, then the asset store comes up and helps us. Version control integration is also important. Personally, this team uses SVM, and we are using C#. This is going to be really important. So this is why we chosen the Unity engine. And we are developing in Unity engine from day one. We prepared 3 demos for you, which you can try in the pause and also after the presentations. You can try out a helmet, which is going to show you the exact same track that Jeb Corliss flew through. We are going to show you airspaces, airways, air traffic. You can see these in augmented reality environment, and thermal maps also. I guess I'm going to skip these because we are all on time a bit, but after the presentation I would be love to talk to you about these things. The game logic, as you can see, a few things. We record tracks and play them back. You can fly through these tracks that you have recorded. You can collect these things, you can go through them. And also we have, as Zsolt said previously, GoPro control, so we can control GoPros as well. So I'm going to give this back to Zsolt.
Yeah, so this is as a spin-off of this project, we created GoPro Tracks, which is a mobile application and also going to be supported by several smart glasses. And you can here see the website, and I want to show you some sneak preview of how an Airglass will look like on GoPro Tracks. So you can see that there is an overlay that you can switch it on and off. We have managed to put the 3D objects in Google Earth as well, so you will be able to see exactly where you flew through. And yeah, this is coming. In this GoPro Tracks we'll have also 360 videos as well that we are going to talk about in the next presentation. And last but not least, we are hiring. We're looking for people who love aerial sports, other kinds of sports, like to solve unique problems, and love to travel to different kinds of events. And we're looking for Unity developers, C# developers, and UI and UX designers. So thank you very much. Questions and answers?
Sorry.
Any question?
I have. When did you start with this development?
2 years ago.
2 years ago, okay.
And the idea was formed like 2.5 years ago.
Okay, cool.
Yes?
And how many of you guys were developing this tool?
Basically, we're...
Please repeat the question for the recording.
Okay. So the question was how many of us are developing it. Basically, there were a lot of people taking part in the development, but now at the moment we are developing 6 of us. So we are working with freelancers, also part-time, that are creating, like, for example, this 3D terrain. We don't need like to create it constantly, but time to time. But we are working also with other companies, for example, how to make fast these 3D terrains. So how are we able to scan? Because with LiDAR you get a lot of information, and you don't want to use all of it in Unity because you're restricted with the mobile, like 100,000 polygons. Any other question? Okay, then I think we'll go to the next presentation, which is basically what the company did from the first days, and it was about 360 imaging. So these are quite old projects, since we are working with Airglass now, and we only focus on some most interesting 360 projects. basically we started with a handmade 360 panoramic robot, and then we thought that this robot is quite precise, so we have started to use telelenses on the robot and create large-scale imaging like gigapixel imaging, and we shoot this image from the Mission Impossible game. We shoot it several paintings, the most famous paintings in Hungary, which is exhibited in the Hungarian National Gallery. We did a line of sight project for T-Mobile. In 2010 we managed to make the world's largest image, which was 70 gigapixel, and we did all kinds of gesture control projects with V-Motion, Airwall. This is a Hungarian invention, goes back to 2010, and we used since then Leap Motion, Kinect, so all kinds of gesture control devices. And we did like we combined 360 gigapixel imaging with visualization. So in this project we are overlaying how the Talentis Valley in Herzegovina will look like. And in the last years, this panoramic imaging went to 360 videos. It got really popular. So we started to experiment with 360 footages. And our first one was in last December, when there are basically two kinds of camera rigs for GoPro, when you put like 6 GoPros in this rig and shoot all kinds of 360 videos with it. We faced problems because these cameras are not synchronized. The triggering is sometimes it's quite tricky. And also when we were shooting in -25, the cameras captured different frame rate. So one of the cameras was shooting at 42 frames per second, the other one was 48. So it was hard after work for Joe. Basically at that time there were no really good stitching solutions. Now both of them out there, Color and Video Stitch, does a really great job. We had to create the UV map at a third-party software as well, PT GUI, to be able to then put it to the Color's rendering engine. At that time there was no GPU support in any of these softwares, and also because of the different frame rates, which should be solved by now, because it was a failure of the 7-disk SD card, they told us. So we had to average all the footages from GoPro. And the output of the file format is quite big, which is still only capable of displaying in dome theaters. So if you capture these high quality footages, it's beautiful for dome theaters, but for tablets and mobiles and also smart glasses, you have to scale them down. So the equirectangular is what you get at the output, and then you can make all kinds of distortion that you can see there as a little planet. So basically, the biggest companies joined their forces. This is Finway and Color, and one of them was concentrating on iOS regarding the player, and the other one is on Android. And they still didn't come out with their product, and we think that they're going on the wrong way because not using Unity. So it takes a lot of effort from them to optimize all these videos and all the player for several hardwares, and every time they make a new function, they have to develop it for 2 platforms. So we decided to check out what can be done in Unity. This is cross-platform common code base, and again fast development time. And 360 videos are great with tablets, but you constantly have to hold it, or the phones you have to hold it, it's tiring, so you cannot watch long movies with it. And in the last couple of years, this VR headset came popular again because of the. Oh, sorry.
Okay, so a lot of VR headsets are becoming popular. You probably know Oculus Rift, but there are others, and these have been in development for the last 20 or 30 years, so it's a really old story. The Oculus Rift, probably all of you know it. It's really popular now. They're developing it extensively and stuff like that. There's also the Sony Morpheus, which is for the PS4 and PS3 consoles. We don't really know a lot about this, but it's supposed to be really good. And also, there's Durovis Dive, which is a really interesting solution. It's basically a piece of plastic, Zsolt is going to show you, in which you can put your smartphone. And the smartphone will provide you with a virtual reality experience. This is really cheap. It's available. You can't really order an Oculus Rift right now, but you can order a Dive. The resolution is really high. It's on par with the Oculus DK2, the development Kit 2. Right now, you can try it out. It's also wireless, so you're not restricted to sitting down in front of a computer. You can walk around in the room. And there's also a head tracking SDK provided for it, which is really easy to use. Which is pretty much drag and drop in Unity, so you can prototype it really fast, and you can develop really cool VR applications in like minutes. Also, we can put in special hardware like the Google Tango, which is being developed, and we're not really supposed to talk about it, but we will be on Google I/O and check it out. We're going to have a big surprise for you. Really check it out. Thanks. Okay, and also we are going to show you a demo for this as well.
Just one more thing about Dive, why we suppose you to buy it. It's like 60 euros, so it's really in your budget. It's for example, maybe you heard about the project where Joe Biogwin was about to fly from the Everest, and we were able to deliver him on the base camp Dive. And there was a tragedy. You probably heard about Sherpas who died it. So basically, Discovery canceled the project, and they are shooting about now the tragedy of the Sherpas. But just imagine that we were able to send them a Dive and an APK, and Joby could practice in the Everest base camp just by putting on the Dive and flying around with his head movements on the virtual mountains. So we think that there is a big hype around the Oculus, but this headset basically provides the same experience, and it's wireless. And yeah, I'm happy to talk about later the speech why we really we think that there is a real problem with Oculus of getting dizziness while you're sitting in an environment and then playing Quake. Mainly, most of us get seasick, and if you're standing up and playing like that, then you don't get seasick. So we don't really see the advantage of a wired solution. Thanks again. Sorry, questions? Okay,
like,
then.
I have a question.
Yeah.
Like you can put a Tango device onto this, and you can use like immediate feedback on it.
Yes, exactly.
Wow. Okay.
So the advantage of the Tango device, basically, for those guys who don't know this is basically a Kinect type of thing embedded in the Tango. So there is an infra projector and an infra camera, so it understands 3D environment, and we really believe that this is going to be the true AR experience. To basically it's possible that monsters are really coming behind those stairs, and so it's not just an overlay, but it gives you a depth map. So yeah, that's something coming.
Anyone? Any questions? We have still a bit of time for questions. Actually, you could maybe shortly tell what we can try with your devices.
Okay,
like,
so we have a 360 video demo here
Yeah.
on the dive. We have this virtual fly-through demo with this in this helmet, and we have this demo for air traffic control and thermal maps on the Epson device. So there is 4 demo waiting for you. Maybe we have the Everest flying as well.
Probably.
Yeah, I think we have it as well.
Wow, great. Okay.
Who's next?
Actually, I'm next. Thank you guys, it's amazing, and I would love to try these tools because it's really amazing to look around and feel that the devices follow your head, and you can just fully immerse yourself in this 3D environment. All right, so thank you very much. I know you see me, so I try to find my stuff before. Just a moment. Yes, I finally closed down the Ustream streaming. Okay. So I'm gonna talk about Unity 3D, and actually it's not Unity 2D, it's 3D, but with 2D capabilities. Like you might know that Unity 4 introduced some new 2D tools that you can use. How many of you know about this? How many of you know these new tools? Okay. Actually, how many of you have Unity installed on your computers? Wow, that's nice. Okay, we have like the majority here. All right, that's nice. So earlier it was mostly 3D, but now you can very easily create 2D games. And I would like to give you a quick overview. What is this? How it works? It will be just an introduction. I have just 9 minutes left, so I will be quite fast going through. So what is 2D? 2D is 2D games started in the 70s. One of the major computers there was Commodore 64, and I was a very happy owner of this computer. And how many of you owned a Commodore 64? Wow! That's nice. Still, like, maybe half? Wow, okay. So you know what I'm talking about. We had amazing fun. For example, this thing, Mission Impossible, I've spent countless hours on with it, and it is like, it was really a exhilarating experience for me. And then, looking back, it seems unbelievable what capabilities that computer used. Officially, it has 8 sprites. Each sprite can have 12 times 21 pixels on a 160 times 200 screen. So it was really basic, but the programmers and game developers there could really excel and deliver us amazing games and amazing experiences. So, this is the time when Sprite started. Actually, two game companies and computer designers realized that mainly a game was a 2D background with graphical objects moving in front. So those computers were slow, so they needed a hardware module to show these fast-moving characters. So they developed this hardware for sprites, and these were all hardware accelerated sprites that time. And now they look like this, and if you can see, each pixel is actually a rectangle. So it is not even a square, it was a rectangle, and you had to build up everything with rectangles. These were those sprites. And in Unity 3D, sprites are not hardware accelerated anymore. They are software sprites, but they are very usable and very easy to implement. And then I quickly show you a demo how you can create sprites. So let's start by creating a new project. So here you see this option here. You just set, instead of 3D, you set 2D, and you create your project. I just saved the one before. So I have a new project here. And as sprite, I can use just 2D. 2D pictures like PNGs or GIFs or PSDs, anything you have, you can use as a sprite in Unity. What you do with it, you copy into your folder. So what I do, I will copy like 4 pictures into my folder. And these 4 pictures will show up in this project window, and immediately they will have this sub-object, and it's already a sprite. What you can do, you can just drag and drop, and you immediately have a sprite on your screen. So, if we want to advance from this, we can have more than one sprites in one picture. Can you clearly see, like, is it visible if I click here multiple? So you click on the picture, you click sprite mode multiple, and then you get into the sprite editor. And here you can automatically slice your picture into sprites. And you can select them and name them as you want. Balint like this turtle here, so I will call this turtle. And I will apply, or which one do you prefer? Do you have any favorite characters here?
Flash.
Flash. Which one is Flash?
Last in the middle. Yeah.
This one?
Yeah.
Alright. That Flash thing, yes. We want that flash, okay? We see that it automatically have found it and try to trim it. And here I set it a little bigger and I hit trim. So then it will optimize my sprite and I can call him flash. And then I just hit apply and flash will appear here and I can immediately use it as a sprite. I don't have that much time left, but still I can apply a coding to it. This is a very simple script that is basically moving the position of itself. So it has a position and in 2 lines it just adds a random number to its position. Just to have a quick overview what it does, I start it and you see it just moves the sprite with 2 lines of code. It's very simple, I know, but I just wanted to show you how simple it is to move a sprite on screen. And in the last 1.5 minutes, I'll show you some test results I had. So, okay, before we start, what do you think, how many sprites can my phone move, this Galaxy S3? What do you think? 1,000? 10,000? Alright, not bad, not bad. I'll show you the results I had because I created this test. This test is adding sprites to a screen in front of a background until frame rate drops down to 25. 25 is still a visible and still a usable frame rate. So the Google Nexus, actually it's in 2012, can move 480 sprites around. Samsung Galaxy, a very common phone now, can move 800 sprites with 25 frames. And with the new Unity version, it can move 20% more. So like with Unity 4.5, you have a bit more capacity. A web player can move 8,000 sprites. And the native PC is like 10,000, more than 10,000 with this 25 frames per second. So actually, as we can perceive 20 or 30 sprites, or maybe 40 on a screen, this means that we have unlimited possibilities to show any 2D context, anything. So we have really reached capacity and the speed of mobile devices where only our imagination is the limit. You can show practically anything, you can move practically anything. So I close with a few resources. There is a very good course on digital tutors exporting 2D in Unity, and then you have 2D game dev. It's a free course. You have a 2D map factory if you want to produce nice maps very easily. Then it is a very useful tool. You can spare hours and hours of work. And actually, that's my presentation. Thank you very much for your attention. Do you have any questions? Any questions? 2D, sprites, Commodore? Not that much, okay. So we will have a 15-minute break now, and then we will continue with Ákos and his Airglass presentation. And see you in 15 minutes then.